Okay, this is obviously the Chapter 6 sample test. And number 1, the directions say simplify each radical expression. And you should definitely notice that we're supposed to use absolute value symbols when needed. So number 1, we want to take the third root of this stuff. Okay? Now, can we take a clean third root of b to the sixth, or do we have to break something off of b to the sixth that we can take a clean third root of? And also you're going to be looking at, can we take a clean third root of c to the third, or do we have to break something off? Well, actually, as it turns out, we can just go ahead and take a third root of b to the sixth, and that's going to be b to the second. So the third root of b to the sixth is just b to the second, and that's just pretty much how exponents work. Okay? And the third root of c to the third, that's also clean, and we can just do the whole thing, and that's just going to be c. So the third root of b to the sixth is b to the second, and the third root of c to the third is just c. And since it's an odd root, we don't even have to even ask ourselves or even consider putting absolute value, okay? When it's an odd root, like a third root or a fifth root and so on, you do not have to guarantee that the final answer needs to be positive. So you just leave it as is. Number 2, this is a fourth root, okay? So we want to take the fourth root of x to the sixth and the fourth root of y to the fourth. Now, we can't take a clean fourth root of x to the sixth, so we're going to have to break off something from x to the sixth that we can. And we can break off x to the fourth, and that's going to leave x to the second, which is still going to be trapped under there. And, the fourth root of y to the fourth, we're just going to go ahead and be able to do that. We don't have to break anything off. Like, we can do a clean fourth root of y to the fourth. So this just becomes x. The fourth root of x to the fourth is just x. This is just going to become y. And this x squared, we can't do anything more with it. It's still trapped under there. Okay. Now, we could put absolute value around the whole thing, and that would be fine. I don't think I'd mark that wrong. Because it's just not wrong. You want, remember, with an even root, you're going to want to guarantee that your final answer needs to be positive. Okay. But I think in this case, and again, feel free to just leave it like this, But I think in this case, we need to have the x inside, we need the absolute value to be around the x, because this x could potentially be negative. We can't allow that. And same thing for the y. Y can potentially be negative, but we can't allow that. Again, not to repeat myself too much, but with an even root, okay, your final answer needs to be positive no matter what. So I think we definitely need that inside of absolute value. But long story short, we're not going to need that. And again, we could have stopped here and we would have been fine. Number 3, this is a fifth root, and so it's an odd root, and so we're not going to need to guarantee any final answer being positive. So look, the fifth root of anything negative is going to be negative. And do we need to break off anything? Can we just take a clean fifth root of a to the fifth? Yeah, and that's just a to the first, or just a. Again, not to like theorize too much and like speculate, but if this was like a to the eighth, we couldn't have done it clean. We would have had to like separate and kind of break it up into a to the fifth and a to the third, just so we could do the a to the fifth, and then there still would have been a to the third trapped under the radical, but didn't have to do that here. Moving on very quickly, number 4, the directions change. It says simplify each expression, so we need to simplify, and we need to rationalize all denominators. But then check out the third part here. We're going to assume that all variables are positive. What that really means is that we do not have to worry about including any absolute value in any final answer, okay? So, with number 4, look, potentially we can simplify just this part. The square root of 3 we can't do anything with, but the square root of x to the third, you could break off an x to the second to do it, and like simplify it a little bit before doing anything else. Same thing over here. You could break off like a 4, from 24 to do it, and you could break off x to the second, and you could break off y to the fourth. But you know what I'm going to do? I'm going to multiply everything together and then see if there's any simplifying. So check this out. Here we go. Here's what we're going to do. This regular 4, already on the outside, can be multiplied to this 2, already on the outside. So that gives me 8. Now, everything else, as far as like the square root of this stuff times the square root of this stuff, all that can be multiplied together. So 3 times 24, oh boy, I'm on the spot here and I don't have a calculator nearby. So 3 times 24, 60... 72. Let me just double check that in my head. 3 times 20 is 60. 3 times 4. All right, that should be 72. X to the third times x to the third. That's going to be x to the sixth. That's how exponents work. We add the powers, people. And then it looks like we have a y to the fifth also. So I multiplied the 4 and the 2 together, and then I multiplied the stuff underneath the square root together. And now we just want to like work on simplifying the square root. So the 8 just comes on down. Now 72. Oh man, I'm going to grab a calculator, I think. So 72. Can we do the square root of 72 clean? No. Can we break off a perfect square? Well, not 16. I just tried 16. 72. 18, no. 72 divided by 9. No, 72 divided... What am I forgetting here? 9, 16, 25. 36. So the largest perfect square that I can break off of 72, so I can do it, is 36. And that's going to leave a 2. So to slow down here a second, root 72 I rewrote as root 36 times root 2, because I can do that one. And as far as x to the sixth, the square root of x to the sixth, do I need to break that up at all? No. I think I'm just going to be able to do that. Okay? Now, the square root of y to the fifth, I can't do that clean, but I can break off that, which can be done, and that's going to leave y to the first trapped. So, here we go. I'll do one more baby step before the final answer. So 8. This is going to become just 6. That I cannot do. This is going to become x to the third. This is going to become y to the second. and this cannot be simplified any further. That's going to stay under the root and be the square root of 2y. And you know what? The only thing really left to do is 8 times 6, which is, see, there was already an 8 out here. This became 6, and so therefore these need to multiply together to be 48. That's all. And that one's done because, you know, because of these directions, I don't even need to think about if absolute value is technically needed anywhere. So that's done. Number 5 is just like okay, I mean, I got to multiply this to this binomial, right? Well, this is going to be the distributive property, basically. The only real question maybe is, should I simplify this first? Should I simplify this first? Should I simplify this first before distributing? I'm going to go ahead and say no. Let's just, even though you could, let's just go ahead and distribute the root 12. So, root 12 times root 8, can we multiply those together? The answer is yes. And so this is going to become the square root of 96 plus, let's see, root 12 times root 24 with a 5 kind of hanging out. So the 5 comes on down, and I can do the root 12 times the root 24. Let me go to my calculator. 288. And so now the issue is I need to simplify now. So root 96. How can I break up? Or can I just do root 96? Let me double check this. Nope. Root 9, I didn't think so. Root 96, you cannot do clean, but can you break off? Yeah. So I can break off that, you know, because I can do the square root of 16. And so I'm going to break up root 96 like this. Root 288, I just kind of came to me here that 288 can be broken up into 144 times 2. So let's kind of take a breath here and realize that I rewrote root 96 as root 16 times root 6, and I rewrote root 288 as root 144 times root 2, because this is just 4, okay? And this is just 12. And so I guess one more step just to, you know, because there was already a 5 out here, and now there's a 12 also out there, and so they're just going to get multiplied together. And since these aren't what we would call like terms, because this is root 6 and this is a root 2, I can't add these terms together because they're different square roots. Like this is the square root of 6, this is the square root of 2, and therefore I'm done. Ooh, here we go. Okay. So, this one, we're trying to simplify, because again, just like I just said, we cannot subtract these two roots together because they would need to be the exact same root. Okay. Look. Again, this is something. Let's kind of step back and talk about, like, I guess the big picture. If you were doing if you were doing the third root of 16 times the third root of 54, you could do it. Like, you can multiply roots together as long as it's the same kind of root. But if you're going to like want to add roots together or subtract roots together, right, from each other, then it needs to be like literally the exact same third root or whatever. So basically like terms, which these are not, okay? So maybe I can simplify this a little bit, and maybe they will be. So here we go. The 3 just kind of comes on down. Now, can I break off something from the 16 that I actually can take the third root of? The answer is yes, it's 8. And so I'm going to rewrite the third root of 16 as the third root of 8 times the third root of 2. And over here, you know, I can't do a clean third root of 54, but I can break off a 27, because I can do that, and that's going to leave third root of 2. Okay, so I rewrote third root of 54 as the third root of 27 times third root of 2. All right, here we go. This is just 2. Okay, and this is just 3. So again, this becomes 6. And this also wow, this is interesting. And this becomes 6. And because it's the same exact root, third root of 2, third root of 2, we can treat these as like terms. So 6 third roots of 2 minus 6 third roots of 2, that's 0 third roots of 2, which is really just 0. Interesting answer. But you know, you can treat this as, you know, you can treat it just like you could treat 6x minus 6x and have them be just like terms. Number 7. I'm going to just cut to the chase. As far as like simplifying this and yada yada yada, I think what you really got to focus on is the part of the directions that say rationalize the denominator. In order to rationalize this denominator, I need to multiply the denominator by the square root of 5x cubed y, like the same thing, okay? And whatever you multiply to the denominator, you also have to multiply to the numerator. Them's the rules. Okay? And so, long story short, what does that make the bottom when you do root 5x cubed y times root 5x cubed y? Well, you just get 5x cubed y, which has made the denominator rationalized. In other words, no more square root in the denominator. Okay? What happens on top? Well, the 6 has nothing really to multiply with, okay? But the square root of this times the square root of that, we can multiply those together. And so there's the 6, and then 3 times 5, we can come together as 15. X times x to the third is x to the fourth. And y times y is y squared. Okay? Now, I'm kind of breaking some pretty serious rules here, you know, but because I know this can be simplified, and this can be simplified, and then there would be more simplifying after that. But you know what? I'm just going to stop right here now that the denominator has been rationalized and we've gotten rid of the square root that was on the bottom. Okay? Number 8. So, same kind of thing where we want to rationalize the denominator. Now, in this situation where the denominator says the square root of 6 plus 2, what we're going to multiply by is the square root of 6 minus 2. which is the conjugate. And once again, whatever we multiply to the bottom, we also have to multiply to the top. Them's the rules. Now, on top, let me change color for the first time. On top, that's just going to be like a very simple distributive property. And so 3 root 6 minus 6 is going to be on top. Okay? On the bottom, when I do this entire denominator times this entire denominator, that's going to mean basically FOIL, okay, or lobster claw method. And so it's going to be all of this, which is going to result in, okay, so root 6 times root 6, that's just 6 at the end of the day. Okay, at the end of the day, root 6 times root 6 is just 6. No more square roots there. That's a good thing. So root 6 times negative 2, that's going to be minus 2 root 6. Because these don't really multiply together, you know, like that's underneath a root. That is not. So same thing here. 2 times root 6, those don't really multiply together because one's underneath a root and one is not. And then what do we got to do here? So positive 2 times negative 2, that's minus 4. Okay? So cleaning this up, the top stays that, and look what happens on the bottom. This term and this term cancel out. I mean, it just works out, you know, because I multiplied by the correct thing, you know, because I multiplied by what I multiplied by. This just works out like, it works like a charm. And so these roots are gone, and the 6 minus the 4 is 2, and, you know, therefore the denominator has been rationalized. Number 9, this multiplying just ends up being FOIL. So here we go, just pretty much doing what we just did, huh? So root 7 times root 7, at the end of the day, that's just 7. Root 7 times negative 3 root 2, well, I mean, the roots can multiply together, and so minus 3 root 14, okay? Like the 7 and the 2 can multiply together. So here, 3 root 2 times root 7. Once again, the roots will multiply together. The 3 doesn't really have anything to multiply with unless you consider that there's a 1 out in front, but whatever. So that's that, and then, okay, so let's see here. When I do this times this, the positive 3 and the negative 3, those will multiply together, and then the roots can multiply together pretty much like in a way separately. And so at the end of the day, root 2 times root 2, which is root 4. But at the end of the day, it's just 2. Okay? So this and this, once again, pretty nice. Those add away, to, like they add each other away, they sort of cancel each other out to like 0. And this is going to be what? Negative 18. And so really we have 7 minus 18, which is what? Negative 11? Why am I doubting that? 7 minus 18 is negative 11. So final answer, negative 11. Yay. Okay. Moving on to number 10. This fraction exponent just basically means that we're doing a power of 2, but also a root, like a third root, sorry. We're doing a third root and a power of 2 at the same time. And so we just got to do both of them. I'm going to do the root first. So the third root of negative 27 is negative 3. But we still have to do the power of 2 to get positive 9. Easy. That's it. Rewatch that once or twice, more, whatever, if you have to, because that was it. Number 11, once again, this 1/2 power essentially means the square root of 2. Just like, same thing here. This 1/2 power just means the square root of 8. And because they're both the same kind of root, we can multiply these together, get the square root of 16, which is just, at the end of the day, 4. Done. Number 12, we're raising this bubble, this 3x to the negative 1/2 power, we're raising it to the negative 4th. So look, this is just going to become 3 to the negative 4th power, and then we're going to also raise this to the negative 4th power. So just think back, how do we raise something to a power that already has a power? Well, you should know from months and months ago that you multiply the powers. So when we multiply those powers, we get positive 2. That's it. Except for, of course, we're not supposed to have negative powers in a final answer, so that becomes that. Okay, 1 over 3 to the positive 4. And, I hope you understand that the bestest looking final answer is going to look like that, okay? So x to the second over 3 to the 4th. Actually, maybe I tell a lie. 3 to the 4th is what, 81? Let me just triple check. Yeah, so actually, I'm going to go ahead and say that the bestest final answer is x squared over 81. Number 13, now we're changing gears. We're going to solve each equation and check for extraneous solutions. Extraneous basically meaning extra. Okay, so here we go. Taking a breath. When we're looking to solve equations like this, the first thing we have to do, people, is isolate the square root, or like the root part. We want to isolate that and have that be by itself. So the very first thing we got to do is get that out of there. Okay? And now we want to undo the square root. And so think to yourself, what's the opposite of doing a square root? What can get rid of a square root? And the answer is raising it to the power of 2. And so the power of 2 and the root will just sort of cancel each other out, and you'll be left with just 3x plus 1, and the other side will become positive 25, right? And now this is like something you've solved 1,000 times. Getting x by itself looks like x equals 8. Let's just sort of double check this a little bit. 3 times 8 is 24. Oh. I knew something was fishy. Well, I need to make a correction here, I think. So if you're watching this video, well, this is funny. If you're watching this video, I bet this says 8. I'm not going to go into like what this answer should, well, there's actually no answer to this. So if you're watching this video, you're probably wondering what the heck I've been doing for the past couple minutes, because what your paper probably says, well, probably, I guess well, if your paper, sorry, So maybe I'll say this. If your paper does not say 8, change it to 8. Okay? Change it to 8. And so what does that mean? That means that that's really a positive 5. Okay? And now that should pretty much fix everything. So to kind of restart here, all right? Again, once again, I apologize. I'm not sure what happened here. But if your number 13 did not say equals 8 to begin with, let's just change it to 8. And so we subtract 3 from both sides, and that gets 5. And we're still going to square both sides and get 25, and then subtract 1, and then divide by 3. And so that holds true for like x equaling 8. And so when we check to see if this is truly an answer, if we plug that in, we're going to get 3 times 8 is 24. And then if we add 1, that becomes 25. And the square root of 25 is 5. And if we add it to 3, we do in fact get 8. So, oops, I need to... So that does check out. Okay? That does check out. Bonus question. Well, this is a very doable bonus question. Square both sides in order to get rid of that square root. Over here, this is just going to be on the right side over here. That's going to be FOIL. And it's going to end up being this once you finish the FOIL and cleaning up FOIL. And this is quadratic. And so in order to solve for x, I'm probably going to need to set equal to 0. And this looks familiar. Like I think this exact same problem was like in our notes or something. And so once you set equal to 0, you factor, and then set the factors equal to 0, and get x equals 7 or x equals 4. Except that if we plug 7 back in, 7 minus 3 is 4. Square root of 4 is 2. 7 minus, okay, so that checks out. So this one checks out. But let's see if this one checks out. 4 minus 3 is 1. Square root of 1 is 1. But 4 minus 5 is negative 1. That does not check out. So the only actual answer is x equals 7. Changing gears again to function operations. So f of x equals this. G of x equals this. To do f plus g, that's just going to be and so we really didn't need the bubbles or the parentheses. And so 7x plus x is 8x, 12 plus 3 is 15. But don't forget about that part of the directions, people. And the domain for this is all real numbers. Because there's no issue, there's no reason why you wouldn't be allowed to plug in whatever you wanted in for x. So the domain is all real numbers. For this one, we're going to do the g function minus the x function. Now here, there's going to be some actual important distributing to do. We're going to distribute the minus sign through the f function, And so now let's see here. We got negative x squared. X minus 7x is minus 6x, I do believe. And positive 3 minus 12 is negative 9, I believe. And as far as the domain, once again, there is no reason why you wouldn't be allowed to plug in anything into that g minus f function. Number 17, it's going to be the g function divided by the f function. And in this situation, we're going to want to simplify if possible, which means factor first. You factor before you do any canceling. The x plus 3 did not factor, but the denominator totally factors into that. And so now we can cancel the x plus 3's and look closely. The final answer is going to be 1 over x plus 4. So that's the final answer for g over f of x. As far as the domain goes, let's see. You're not allowed to plug in anything for x that would have you dividing by 0. So because of this factor, x would not allowed to be able to equal negative 4. But also because of this factor, we would not be allowed to plug in negative 3. So there's my domain. It could be anything except negative 4 or negative 3. Otherwise, you know, because if you had those in for x, you'd be dividing by 0, which is not allowed. And so that's the domain of number 17. Number 18. Okay, here we go. So now we're going to plug in, like we're not going to plug in 7 in for f, we're not going to plug in 12, we're going to plug in the g function. So here we go. When we plug in, you know, again, for example, if I would have wanted you to do f of 3, then it would have been 3 squared plus 7 times 3 plus 12. But we're not plugging in 3, we're plugging in x plus 3 in for the x. And so that's what I'm doing. So I'm plugging in again x plus 3 in for x. And there it is. So wherever we see an x, we're going to plug in the g function, which is x plus 3. And so this is just going to be now cleanup. So this is going to be FOIL. And at the end of the FOIL, it's going to be this. And then this is going to be needed, you know, this is going to need distributing. And so there's that, which is, and then, and x squared, oh, no. So there's nothing that'll combine with that, but that's going to make 13x, and that, and that, and that should make 42 as the final answer for f of g of x. And for this domain, there's no reason, like there's no denominators, like there's no reason why you wouldn't be able to use all real numbers for your domain. Okay, now look, this is g of f of 2. Okay, so first, here's what we're going to do. We're going to find f of 2. So off on the side here, f of 2 equals 2 squared plus 7 times 2. Right, maybe I'll even do that a little bit. So 2 squared, we're plugging in 2 for x. And then the rest of it is plus 12. So that's 4, that's 14, and then 30. Wait, yeah, 30. And so f of 2 is 30, and so this becomes g of 30. So when we think about we need to plug in f of 2 in for the g function, that really just means we're going to plug in 30 into the g function. And so here's the g function, and we're going to plug in 30 into the g function, and so the final answer is 33. And I know the directions mention domain, but those directions about domain do not apply to number 19. It wouldn't make any sense to find the domain of something that's not even really a function, okay? Anyway, number 20, well, number 20, chances are number 20 does not even count on your test, okay? So we may not even have gotten to talking about the inverses of functions, and so number 20 might not even count for you. But if it does, here we go. Finding the inverse function really just means that you switch x and y. The output becomes the input becomes the output, and really, to take the inverse of a function, step 1 is to switch x and y. And the only thing you have to do to finish this up is get y by itself again, which means we're going to add 3 to both sides, and then it looks like we're going to divide both sides by 2 and get here. And it looks like the final thing we need to do to get y all by itself is undo that power of 2, which means take the square root of both sides. And just, you got to remember that. And also, I'm going to like swap sides, you know what I mean? Like I'm going to put this on the left and this on the right. So y is by itself, and I guess the only thing you got to keep in mind is that technically it's plus or minus